Venus, our closest planetary neighbour, is often called Earth's evil twin, a moniker that may seem strange at first glance, but as we delve deeper into the mysteries of this celestial body, we begin to understand the stark contrast that lies beneath the similarities. Venus, named after the Roman goddess of love and beauty, is anything but inviting. It's the second planet from the Sun, just one step further out than Mercury, and our closest neighbour in this vast expanse of space, a mere 26 million miles away. A short hop, skip and a jump in cosmic terms. And yet, despite its proximity and its comparable size to our own planet, Venus is dramatically different. Imagine a world shrouded in thick, toxic clouds of sulphuric acid, where the ground is a barren landscape of volcanic plains and mountain ranges. A world where the air pressure is 92 times that of Earth, enough to crush a submarine, and the temperature on a typical day reaches 864 degrees Fahrenheit, hotter than the surface of Mercury, the planet closest to the Sun. But it wasn't always this way. Venus and Earth are roughly the same age, both formed about 4.5 billion years ago from the same swirling disk of gas and dust. They're almost the same size too, Venus being just a smidge smaller, and they're both located in the Sun's habitable zone. So, what went so drastically wrong? How did Venus become the hellish world it is today, while Earth became a haven for life? The answer lies in a runaway greenhouse effect, a cautionary tale for our own planet. But that's a story for another time. For now, let's marvel at the enigma that is Venus. A world so similar yet so different, a world that holds a mirror to our own and forces us to ask the hard questions. Would you believe, despite its hellish environment, Venus might have once been quite Earth-like? Venus's atmosphere is a deadly cocktail, far from hospitable. But what exactly makes it so inhospitable? Well, at the heart of it, Venus's atmosphere is mostly composed of carbon dioxide, about 96% to be exact. A small fraction, around 3.5%, is nitrogen, and trace amounts of other gases make up the remainder. But it's the sulphuric acid rain that truly sets Venus apart. These aren't the kind of gentle showers you'd experience on Earth. Instead, imagine a downpour of corrosive acid that could dissolve metal on contact. This thick, dense atmosphere creates a significant greenhouse effect on Venus. The greenhouse effect, in simple terms, is the warming of a planet's surface. On Earth, our greenhouse effect is beneficial, keeping our planet warm enough to support life. But on Venus, it's a different story. The dense carbon dioxide traps the sun's heat, causing temperatures to soar to an average of 467 degrees Celsius. That's hotter than the surface of Mercury, despite Venus being nearly twice as far from the Sun. This extreme heat, combined with the crushing pressure of the planet's atmosphere, about 92 times that of Earth's, akin to being 1 kilometre deep in Earth's oceans, makes Venus the hottest planet in our solar system. It's a world of roaring winds, swirling clouds of sulphuric acid, and a surface scorched and reshaped by volcanic activity. And if all this isn't enough to dissuade would-be space tourists, consider this. Venus's surface is so hot that it could melt lead. That's right, the soft, heavy, malleable metal we use to shield against radiation would simply turn into a puddle on Venus's surface. So, as we continue our journey through the solar system, let's remember that not all planets are as welcoming as our own. Venus, with its deadly atmosphere and extreme temperatures, certainly gives us a new perspective on what it means to be a hospitable planet. Time takes on a whole new meaning on Venus. Indeed, we are about to venture into a realm where days outlast years, a place where clocks would seemingly run backward and calendars would be utterly redundant. This is Venus, a world where time dances to a different rhythm. Sit back and imagine a day that lasts longer than a year. Confounding, isn't it? Yet on Venus, this is the stark reality. A single Venusian day, the time it takes for Venus to rotate once on its axis, stretches out for a staggering 243 Earth days. Contrastingly, a Venusian year, the time it takes Venus to orbit the Sun, is a mere 225 Earth days. You might wonder, how can this be? The answer lies in Venus's leisurely spin. While Earth pirouettes on its axis roughly once every 24 hours, Venus takes its sweet time, twirling around just once every 243 of our days. This sluggish pirouette makes a Venusian day longer than its year. But what causes this languid rotation? It's all down to Venus's thick, heavy atmosphere. This dense blanket of gases creates a powerful drag that slows Venus's spin to a crawl. It's akin to trying to dance underwater, where the water's resistance turns every twirl into a languid swirl. This might make for a strange existence if you were to call Venus home. You'd celebrate your birthday before a day had even passed, imagine that. You'd age faster than your days, a notion that puts a unique spin on the concept of a midlife crisis. And so, we see that time, like beauty, is relative. It's a construct that can warp and stretch depending on where in the cosmos we find ourselves. On Venus, it seems time is a slow waltz, a dance that defies our earthly perceptions. So, if you lived on Venus, a birthday party would come faster than a day at work. A whimsical thought indeed, but a testament to the extraordinary diversity of our cosmic neighborhood. Venus likes to do things her own way, even when it comes to spinning. While most of the planets in our solar system, from Mercury to Neptune, spin in the same direction they orbit the Sun, Venus prefers to be a bit of a rebel. She spins in the opposite direction, a phenomenon we refer to as retrograde rotation. Now you might be wondering, why does Venus insist on being the odd one out, the planetary equivalent of a nonconformist? Well, the truth is we're not entirely sure. But as with all great mysteries, we have a few compelling theories. One theory suggests that Venus originally spun in the same direction as most other planets. However, over billions of years, the planet's dense atmosphere could have acted like a giant brake, gradually slowing down its rotation. Then, the gravitational influence of the Sun and other planets might have nudged Venus to start spinning in the opposite direction. Another theory involves a catastrophic event, like a massive collision with an asteroid or another planet. This collision could have been so powerful that it completely reversed Venus's spin. Imagine that, a cosmic fender bender causing a planet to do a 180. Yet another theory argues that Venus's retrograde rotation could be due to tidal effects. Over billions of years, the gravitational pull from the Sun could have slowed down Venus's rotation and eventually reversed it. Of course, these are just theories. We still have much to learn about our mysterious neighbor. What we do know is that Venus, with her retrograde rotation, reminds us that the universe is full of surprises. She's a celestial rebel, spinning in her own way, indifferent to the cosmic norms. It's as if Venus decided to dance to her own tune. Venus has a water mystery that has puzzled scientists for decades. This celestial neighbor, often dubbed as Earth's twin, shares a similar size, mass and composition to our home planet, yet it's a world apart when it comes to water. There's compelling evidence that Venus once had rivers, oceans, maybe even life. Scientists have found deuterium, a heavy form of hydrogen found in water, in Venus's atmosphere. It's found in abundance, which suggests that Venus once held vast quantities of water. But here's where the mystery deepens. Today, Venus's surface is bone dry. So where did all the water go? This question has been the subject of scientific debate for years. One theory suggests that Venus lost its water to space. The Sun's ultraviolet radiation could have broken water molecules into their constituent hydrogen and oxygen atoms. Over time, the lighter hydrogen atoms would have escaped Venus's gravity, leaving behind a dry, barren world. Another theory points to Venus's lack of a magnetic field. Earth's magnetic field protects our atmosphere from the solar wind, a stream of charged particles from the Sun. Without this protection, the solar wind might have stripped away Venus's atmosphere, and with it, the water. Yet another theory suggests a catastrophic event, perhaps volcanic activity or a massive asteroid impact that would have boiled off the oceans and sent the water vapor into space. These theories, while intriguing, are not definitive. The vanishing water of Venus remains one of the great unsolved mysteries of our solar system. So, the next time you enjoy a glass of water, remember, it's a luxury Venus doesn't have. Exploring Venus is no easy task, but it hasn't stopped us from trying. The second planet from the Sun, often referred to as Earth's evil twin, poses significant challenges to human exploration. Its thick, toxic atmosphere and surface temperatures hot enough to melt lead have made it a formidable adversary. Despite these challenges, our curiosity has driven us to launch several missions to Venus. The first successful mission was the Mariner 2, launched by NASA in 1962. It was a flyby mission that gave us our first close-up view of the planet, revealing a world shrouded in thick clouds of carbon dioxide and sulphuric acid. The Soviet Union's Venera program was the next to tackle Venus, sending a series of spacecraft between 1961 and 1984. These missions were the first to land on another planet, endure the harsh conditions, and send back data. The Venera missions gave us our first glimpse of Venus's surface and provided valuable information about its atmospheric pressure and temperature. More recently, the European Space Agency's Venus Express orbiter spent 8 years studying the planet's atmosphere and weather patterns. The Japanese Aerospace Exploration Agency's Akatsuki mission is currently orbiting Venus, studying its climate and surface to understand why it evolved so differently from Earth. Each of these missions has played a crucial role in expanding our knowledge of Venus. They have helped us understand its volatile atmosphere, its scorching surface temperatures, and its complex geological history. Yet, despite our best efforts, Venus remains a world shrouded in mystery. Our quest to explore Venus continues. Future missions like NASA's planned Veritas and Da Vinci Plus missions aim to unravel more of Venus's secrets. They will probe its crust, investigate its atmosphere, and search for signs of past water. Who knows what secrets Venus still hides from us? As we continue to explore, each mission peels back a layer of the unknown, bringing us one step closer to understanding our enigmatic neighbor. Venus, a world of extremes, continues to fascinate and puzzle us. This enigmatic neighbor, shrouded in a deadly atmosphere so dense it could crush a submarine, remains a source of endless fascination. Its day bizarrely stretching longer than its year, and its retrograde rotation spinning in a direction contrary to most other planets, are peculiarities that continue to baffle scientists. The mystery of its vanished water, a riddle that could hold clues to our own planet's future, adds another layer to its intrigue. And yet, despite the harsh and inhospitable conditions, our quest to explore Venus, to delve into its secrets and understand its past, continues unabated. Each mission, each discovery, peels back a layer of the enigma that is Venus, bringing us closer to unlocking the secrets of our solar system. The journey we've taken today is just a glimpse into the wonders that our universe holds. Each planet, each celestial body we explore, brings us one step closer to understanding our place in the cosmos. And Venus, with its harsh conditions and perplexing mysteries, serves as a stark reminder of the diversity and complexity of the universe we inhabit. By delving into the mysteries of Venus, we don't just learn about a distant planet, we learn about ourselves, our home planet, and our place in the universe. It's a journey of discovery, a journey of understanding, and a journey of curiosity. If you've enjoyed this journey to Venus, give this video a thumbs up, hit the subscribe button, and join us as we continue our voyage to the next stop, Earth. Remember, the universe is full of mysteries waiting to be unraveled. Stay curious,